Hello, friends. Welcome to my channel, Academic Made Easy Peasy. If you have not subscribed my channel, subscribe it and also click the bell icon.
Vector algebra. Hope this topic is very new to you all. So now let me make this topic very simple. So vector algebra. Hope everyone know what is algebra. So algebra is nothing but that deals with variables, say x, y, z, etc. Some variables. Okay, so now vector, let me explain what is vector. So vector is nothing but it is a quantity that has both directions and magnitude. The quantity that has direction and magnitude is called a vector. So now vector is especially denoted with a symbol. So what is that symbol? Is that it is just an arrow. Okay, so now simply we can't just denote vector with arrow. We will be using some variables. So that variables is algebra. So now hope that you will be clear with what is vector algebra. So vector is nothing but it is denoted with arrow and it has both the direction and magnitude. We can't just denote vector with an arrow. We will be dealing with some variables. That variables is algebra. So now you will be clear with vector algebra, I hope. So now let me give you all an example. So consider 2 points A and B. Okay, so now I'm joining these two with a arrow mark. Okay, so this will be denoted as AB vector. An arrow mark on the top of the variable. We already know that any line A and A to B, where the point A to B is denoted as AB, right? So since it is vector, we are denoting with an arrow mark. Okay, that is the only difference between a vector and the line. So now there are some important points that had to be made note. So now this point A, no, this is the point where the vector is starting. So that point, starting point is called as initial point of the vector. Okay, and where the vector ends, no, that is called the terminal point. Ending point is called terminal point of the vector. Okay, it is called the terminal point of the vector. Okay, so you all know what is direction, right? In vector definition, I gave you direction and magnitude. So you all know what is direction, but you all don't know what is magnitude. Even if you know in algebraic, vector algebraic term, you will not be familiar with the term magnitude. So now what is magnitude, you all might ask. So magnitude is nothing but it is the difference between or the distance between A and B. This is called magnitude. That is the point B, no? So from this point A to B is called the magnitude. That is distance between A and B is called magnitude. Okay, so now there is a special a way of representing magnitude. That is nothing but AB with a vector. Okay, so now you will be enclosing with a mod. So now you all might ask whether we have to represent it as AB vector alone. Of course not. You can just name with any variable for this vector. So for example, I'm naming this vector as a vector. So now this vector can be called as a vector alone instead of AB vector. So but AB vector is equal to this A vector because both the vectors are same. And now, one more important note that had to be made is the vector is starting from this point A to B. So only we are writing it as AB vector. So now you all might ask a question, can we write it as BA vector? No, that's wrong. So AB vector is not equal to BA vector. Okay, so if the vector is moving in this direction, that is right from left to right, you have to write the point that is in left side, then the right side. Okay, so if you want to write be a vector, then you will have to add a minus sign in front, which says that it is written in reverse order. That is, AB vector is written as minus BA vector. Okay, so this minus symbol is very, very important if you reverse the order. That is, terminal point first and the initial point second. Okay, so it is always advisable that write the initial point first and then the terminal point second. Okay, and as we all know, the length of any line cannot be negative or 0. The magnitude is always greater than 0. Never ever you can't get a negative sign as your magnitude. Okay, I hope you will be clear with this introduction part. So now let us move on to more topics. Now, the next important topic is direction cosines and direction ratios. So now, let us see direction cosines first. The angles alpha, beta, gamma made by vector r or r vector with positive directions of x, y, z axis are called direction angles or direction cosines. So, you all might get confused seeing the definition, and don't get scared, it's very easy only. So now consider this 3D graph with x-axis, y-axis and z-axis, and I have drawn a vector that is r and I have denoted with an r, so that is called an r vector. So now I'm just going to form an angle that is made by the r with x-axis, with y-axis, with z-axis separately. So now I'm just taking x-axis first. So from this x-axis to this position r, we all know, right, whenever we take any quadrant we will be going in anti-clockwise. So the same way I'm just going for 3D graph also. So I'm just going from x-axis to this position vector or vector r, so that I'm getting an angle alpha. I don't know what angle is it, but I'm denoting it as alpha. Then I'm moving from y-axis to the vector r. So I'm marking this angle as beta, and from z-axis to this position vector, this one I'm marking it as gamma. From this position vector to z-axis, I'm marking it as gamma. So now these angles are kept separately. So as the name suggests, direction cosines. So we are going to take cos of the angles that we have found. Alpha for x-axis to this r, and for y-axis it is beta, and for z-axis it is gamma. So the cosine of these angles are called direction cosines. Okay, so now cos of alpha is denoted with L. This is the general term that I have given you all. So cos alpha is denoted with L, and cos beta. Don't see this one, so just consider this. So cos alpha is denoted with L, cos beta is denoted with M, and cos gamma with N. So now if you just take a cosine of this triangle, see, I have marked with a dotted line. Hope this is visible. If you just take cosine of beta, so what is cos? It is adjacent by hypotenuse, right? So what is adjacent here? It is y, and the hypotenuse is r vector. So only I've written as y by r. So similarly, if you just take for x-axis, it will be x by r. So even if you take for z, just draw a dotted line here. So here, what is my adjacent? It is z, and my hypotenuse is r. So z by r. This is how I get my direction cosine. So I think you will be fine with direction cosines. So now let us move on to direction ratios. So direction ratios are generally denoted as DRS. It means direction ratios. Okay, this is a plural form of direction ratios. So DRs are numbers which are proportional to direction cosines. Okay, so we are just taking the proportionality theorem over here. It is nothing but, instead we wrote, right, L equals x by r, m equals y by r, and n equals z by r. The same thing, instead of x comma y comma z, they have taken it as a comma b comma c. Okay, so a, b and c, and root of a square plus b square plus c square. So that is the magnitude of r. Okay, so always please make a note, magnitude of r. Generally I'm just saying magnitude of r will be written as a square plus b square plus c square. Let us assume that r vector equals a I cap plus b j cap plus c k cap. Okay, so in that case we will be having this as the magnitude. I have not said in the previous topic, so make a note of it. Okay. So now direction ratios as well as direction cosines is same, that is proportional. They are proportional. Okay, so DRs of line joint px1 comma y1 comma z1 and qx2 comma y2 comma z2 are taken as from this point. If you're taking from P to Q, then you have to subtract the point of Q to P. Okay, so x2 minus x1, y2 minus y1, z2 minus z1. Okay, and one more important note is that always whenever you square the direction cosines, that is L square, M square, N square, see, I have given here, no? So whenever you do so, L square plus M square plus N square always gives you 1. This can also be written as cos square alpha plus cos square beta plus cos square gamma is equal to 1. These both are also same only, but since we said the direction cosines and direction ratios are proportional, but this case is not satisfied for direction ratios, that is a square plus b square plus c square is not equal to 1. That is totally different. So while we do the sums, I will explain you why is it so. Now let us see an important topic, that is types of vectors. This will be asked in 1 marks or 2 marks. Okay, mostly in 1 marks you will be asked what is a zero vector, or asked to find what is zero vector, co-initial vector, etc. So you just be careful and listen attentively. So now we are going to see types of vectors. We have totally 7 vectors that is mostly given in our syllabus. So now we will be just seeing one by one. So first let me just introduce you to the types of vectors. First is zero vector, then unit vector, co-initial vector, collinear vector, equal vector, negative of a vector, and free vector. So in this you will be mostly concentrating on zero vector, unit vector, and equal vectors. These are very important. In these three, unit vector is very important. Wherever you are studying mathematics, this unit vector will be used. So now first let's see what is zero vector. So zero vector, as its name suggests, it is nothing but zero. So but it is represented with an vector symbol. Okay, so zero vector is nothing but it has no magnitude, that is magnitude equals 0. Okay, magnitude of the given vector is 0, then it is called a zero vector. So now let's learn about this unit vector, which is very important. So unit vector, this is denoted with a cap on top. Okay, so this symbol is very important. So u cap is nothing but it is a unit vector. You can represent this as a cap or b cap, etc. So I'm just taking for example as u cap. So this u cap is nothing but u vector divided by mod of u vector. Okay, this is what unit vector. Unit vector is always equal to 1. So since we have to make it as 1, we are taking this u vector divided by mod u vector as unit vector. Unit means what? It is just 1. So in order to make the given vector as 1, we will be taking this as unit vector. So this, we will be learning more about this in the upcoming lectures. Next, co-initial vectors. The third one is co-initial vector. Co-initial vector. So co-initial. So we have already learnt initial point of the vector. So co means what? Something together. So any vector that has same initial point. Say it has O, A and B. So OA vector and OB vector has the same initial point. So only it is called as co-initial vector. This is what the thing, but the magnitude here can differ. It is not that magnitude of OA and OB should be equal. It is not necessary. Co-initial means what? The initial point of any 2 or 3 or many vectors that has same initial point. That's it. Next, collinear. Collinear vector can also be said as parallel vector. Parallel vector. We already know what is collinear. Collinear is nothing but it lies on the same line. Okay, here in collinear vector we can say that two vectors are parallel or in a straight line. Okay, that is what collinear means here. So the magnitude or a vector will be denoted as collinear if and only if a vector equals to some number. I'm keeping it as lambda b, or b vector equals lambda a vector, something like this. Okay, so let us learn about this detailedly in the upcoming lectures. Just know what is what in this video. So collinear and parallel vector will be clear, I think. So equal vectors means the vectors that has same direction and same magnitude. That is called equal vectors. So for this will be AB vector equals CD vector. Okay, these two vectors are equal if and only if AB magnitude is equal to CD magnitude, and the direction of AB should be equal to direction of CD. That's it. This is what equal vector. So negative vector, as I said you in the first introduction part. So for example, let us take AB. Okay, so this should be written as AB vector only. Okay, so if I have to write it as BA vector, then what did I say? I said you have to insert a minus sign. So this is what the negative of a vector. This is the original vector, that is AB vector. The negative of a vector will be minus BA vector. So you can't just write it as B minus AB vector. This is totally wrong. Okay. So this is totally wrong. You have to write it in this way only. So in that case, we will be saying AB vector equals minus BA vector. So now negative of a vector is over. So now what is a free vector? Free vector is nothing but a vector that is changing or displacing its position from one position to other without changing its magnitude or direction is called a free vector. So the vector that has same magnitude, only one vector is dealt in free vector, okay, same magnitude and same direction, but it is changing the position of the vector, or it is displacing. Okay, a vector that is displacing itself or changing its position but without changing its magnitude or direction is called a free vector.
If you have any doubts, mention it in the comment box.